Hey everyone, Sebastian here, back to give you another video of just hard questions. This one is on inference from sample statistics and margin of error. So it's very statistically minded. I've done a full video, easy, medium, and hard, but for the people who just want to do the hard ones, try these out, see how you do on them, and let me know. In a study on maternal running habits, 240 randomly selected moms were asked how often and how far they ran. The data are summarized in the table to the left. Based on the data from the study, an estimate of the percent of moms who run daily and at a distance between 6 and 10 kilometers is 11.25%, with an associated margin of error of 1%. Which of the following is a correct statement based on the given margin of error? So we have this chart. We're actually given a lot of information that it's 11.25% between 6 and 10 kilometers, right? So who run daily and at a distance between is... So they run daily, so it's this people, right? So it'd be 27 out of 240, and they're telling us it's 11.25%, and normally you can trust them, but if I did the math on this, I would get that it's 11, it would be 0.1125. Okay, and then it has an associated margin of error of 1%, which isn't really going to be written here at all, so we just add and subtract 1%, so we have 11.25 plus 1%, 11.25 minus 1%, and we'll get 12.25% and 10.25%, right? Again, you wouldn't have to write this out. This is something you could do in your head, and I don't think you really have to check. They're pretty consistent about giving you these values and being accurate with them, and I think the chart is here almost just to waste your time and throw you off, but I wanted to show you that it does line up. So approximately 10% of moms run daily. That's not really what we're asking here, right? We're based on moms running daily between 6 and 10 kilometers. B, it is likely that between 10.25 and 12.25% of moms run daily and between this distance of 6 and 10 kilometers. So that really narrows it down, right? You're running daily, 6 and 10 kilometers. It's this that we were focused on. So it could be B, it probably is, but we'll check the others. There's a 1% chance that 11% of moms run daily and at a distance of 6 to 10 kilometers. No, they're not reading what margin of error means, and there's a 99% chance that 11.25% of moms run daily and at a distance of 6 to 10 kilometers. Again, not understanding the values, so it is B. And again, you could do this one without writing anything down. It'd be pretty quick, even though it's a hard level question. And as a chart, sometimes the chart is useful. If they give you the info, you don't have to work that out, and then you just work with the percents. So we'll go on to the next one. We have to estimate something where we're combining values and go from there. So a survey of college students at a university were asked their opinions on lowering taxes on the rich. The data are summarized in the table to the left. If the school has 20,000 students and the data is representative of the school, what is the best estimate of the number of students at the university who either strongly or somewhat oppose lowering taxes on the rich? So strongly or somewhat, I would fall into that category, but you would do 64 plus 35, and that gets you 99. And then if we add up the other parts, we're going to have 19 plus 31 plus 31. And that's going to give us 81. So plus 99. All right, and you could just use your calculator for this, but I'm working it out here as 180. So the proportion would be 99 out of 180. And you would multiply that by 20,000. And that would give us 11,000 students, okay? So that would be the best estimate. And sometimes they might not even say best estimate, even though it should be an estimate. But when they say it's representative, that's saying it's very accurate to the whole population, so you can just use that value. Okay, so for this one, it would just be 11,000. It's nice and clean. There's no answer choices. And it just takes a bit of adding and dividing to work it out. But you just have to feel confident about knowing what to do. And I think watching this video will help you feel confident. And always ask me questions if you still have doubts. So here again, you notice, right, that a lot of the hard questions all have charts. They like to have that in there either to read and give you info or to throw you off the scent. 3 random samples of townsfolk, ask them if they run as a form of exercise. The samples are selected from the same population and the margin of error is calculated using the same method. Which of the following is the most appropriate reason that the margin of error for sample B is greater than the margin of error for sample C and less than the margin of error for sample A? Okay, so margin of error for sample B, right, is greater than C, but less than A. Why would that be, right? Sample B had higher response rate than sample A and a lower response rate than sample C. Sample B had a larger sample size than sample A and a smaller sample size than sample C. Sample B had a smaller sample size than sample A and a larger sample size than sample C. And D, sample B is closer to 50%. So this is testing if you understand how margin of error is developed, right? And the way margin of error works is the bigger your sample, the more confident you are, and the smaller the margin of error. So it should be B. Sample B is going to have a larger sample size than sample A. That's why its margin of error is smaller, because you're more confident because you've done more data collection. But it'll be bigger than sample C because sample C had a bigger size. So the people who did that are even more confident. So this is an abstract conceptual question, no real math involved, just asking to see if you understand how margin of error and sample size are related. And then this is our last question, right? It's the fourth type of question in the hard level. In the town of Haines, 30 doctors at a hospital are surveyed. 33% say they don't have children. There are 30 hospitals in Haines, and the average hospital has 60 doctors. If the surveyed doctors are representative of doctors in Haines, which are the following best estimates of the number of doctors who have children in Haines? So basically we're told that 33% of doctors don't have children. And it's asking for the number of doctors who have children. So that would be 67%. So if we have 60 doctors and there are 30 hospitals, right? We would do 60 doctors per hospital times 30 times 0.67. And that would give us 1,200. So 1,200 doctors would have children. Okay, so it's an estimation problem. Not too bad. I think it's just straightforward. It's very subtly made harder just by the fact that the hospital we're serving has 30, but then the average hospital has 60. And we do 60 times the 30 hospitals to find the total population. And then we're given 33% don't have children, so we have to find the percent who do have children, which is found by doing 100 minus 33. So if you have questions on this one, let me know. All right, well, I hope you enjoyed the video. Let me know if any of the hard questions are really hard, or if you thought some were probably more easy, medium level. I'm going off of what the SAT says is hard or easy or medium, so maybe they're wrong about some of it. But these are definitely challenging. You have to think about them creatively. So I'll talk to y'all soon. I hope it's sunny where you are, but if it's raining, I hope the rain is cleaning your windows and watering your plants. Bye.